Well, good afternoon, everyone, and welcome to the First Nations Launch 2023 Avionics Webinar. We are excited to have everybody here, and we look forward to a great webinar that gives lots of information and will help you to be more successful at this year's competition. We do want to welcome one of our FNL alum and also one of the individuals that will be in on the Gateway Challenge presentations, both virtually and while we were at Carthage College for the competition. He also will be joining us at the launch site and working in the pit area with us. So I do want to welcome Aaron Ashley, System Safety Engineer at Raytheon Missiles and Defense. And thank you, Aaron, for always your continued support of this program. I think that's enough for me. I'm going to go ahead and let you get started.
All right. Yeah, thanks, Christine. Yeah, welcome everyone. Thanks for the intro. I'm also Crow Creek, Sioux, and Omaha is my tribal affiliation. So hopefully we'll get some good info in for you guys today. So this is kind of how we broke it down. We'll start with the off-the-shelf altimeters and then how to switch and power them. And then a separate topic is trackers. And then we'll talk about how you house all that hardware in the rocket. So when we talk about avionics, we mean the electronics that you put in to control the flight of the rocket, and that could mean how high it goes or where on Earth, like GPS coordinates it goes. And we differentiate that when from payload electronics. That doesn't apply this year so much because your payload is more the structure, but sometimes the payload challenge will include a separate electronics, and normally that'll be built separate from the avionics that is used for the flight stability of the vehicle. So the altimeter is the main device or the baseline device we use, and COTS just means commercial off the shelf. And we encourage, actually require off the shelf, because if we allow you to build your own, it may not function as intended. So therefore, we need an off the shelf one just to show how high you go, because that's part of what you're scored in the competition. And the standard way that altimeters measure how high the rocket goes is a pressure sensor. Basically, it just takes the pressure as it goes up, and then it compares it with the table for like this many millimeters of mercury corresponds to this many feet in the air, and then it'll report that when you recover the rocket. But others will have a lot more fancy sensors in it, like accelerometers or other flight computer data logging or transmitting. But the baseline is the pressure sensor is what you need in your rocket. And we sometimes use that pressure data, the altitude data, to trigger your flight events. Like if you use more than a motor eject for a dual deployment rocket, that means you need to have your motor eject at the top, and then at a certain number of 100 feet or 200 feet from the ground, you have a second black powder charge. That altimeter knows that 200 feet has been achieved with one of these barometric altimeters. So that's another use for these altimeters. And the altimeters that control those flight events, Drogan Main as a review if you were at either of the Launch to Learn workshops. And in addition to having that pressure sensor, the electronics on it it'll give enough battery charge to the black powder to deploy it. And it's important you test that and know how it works So don't just buy it right before the launch and then expect like, oh, I'll figure it out on the launch pad. You need to really understand how the user interface for it works and test it a few times if you can. And if you need help with that, your rocketry mentor can help with that as well. And if you have a vacuum chamber at your school or at your disposal, that's a good way to test that. You could put the altimeter in there all powered up, connected to your computer or the interface, if it's a phone or whatever, and then pump the vacuum down to the pressure and it'll think it's going up in altitude. And instead of black powder, you could put like a Christmas light or something like that to see when the black powder charge should have gone, and you can verify that it works how you intend to. So that's an idea as well. And then there's the more simple ones, as I mentioned, and then there's more complex ones. So the simple ones is there are altimeters that literally just record the altitude and nothing else. But the ones that can deploy the parachutes, it records altitude and deploys the parachutes, such as that stratologger. That's a pretty tried and true one, or the featherweight Ravens are a pretty good one too. Those take the altitude and also deploy your drogue and main charges. And some of them have kind of built-in safety interlocks, like it has to be going a certain speed, or it has to not be under thrust, something like that, and that'll be within that computer algorithm. And then more advanced ones, it has more than just the pressure sensor. It can have accelerometers, gyros, or more data logging techniques, or even a tracker too, like that telemetrum up there. That's a pretty pricey one, but it has a ton of features in it, and tracking we'll go over later. But yeah, the gyros and accelerometers, it can give you a lot more data from your flight, like how fast it went, where it went, what direction it went, stuff like that. So when you put these in your rocket, it's important to know a reliable circuit setup, because sometimes when we put these altimeters in our rockets, they'll fail, and if it fails and the parachute doesn't deploy at the right time, that's obviously not ideal. So what we recommend is to have redundant altimeters, and not just the altimeters, but completely separate circuits. So the battery that's connected to the altimeter, you need two batteries and two switches, because if you don't have two separate batteries or switches, if one of those fails, it takes out both of your altimeters, and that defeats the purpose of redundancy. So the redundant circuits is something we definitely look for in your reviews and in your designs. And some of these pictures were on previous ones, but these are some example brands that you could look for altimeters. So another topic I wanted to emphasize is the switches that turn on your electronics. There's certain ways they need to function aside from having one switch per circuit. It needs to be accessible from the outside of your rocket. So once you pack everything in, you need to be able to turn it on while your rocket is on the pad, almost ready to launch. And typically how we do that in the designs you guys do is in your, let's see, there's a diagram later, but your payload bay will typically have like a 1-inch band around it that is separate from the the booster and sustainer tubes, and you could drill an access hole in there, and we call that a switch band. So that's an option, but I'll touch on that later. And oh, thank you, Frank. Frank is showing an example of a switch band with the switch mounted on it. And a lot of mishaps we've had with switches for them being inadvertently activated when they're launching, or a team was prepping at the launch site and the switch failed and just no longer worked, so they were left without a switch. Actually, that was my team included when I was a participant. But so typically the most reliable ones are these screw down switches or something that's magnetically activated, like you take a magnetic key off of it. And we generally encourage against these toggle or slide switches. Like you generally think of like a light switch in a room, or like the on and off switch on the back of a toy is a slide switch, or the toggle switches are like in an aircraft cockpit that you put your finger like up and down on it. Those are handle and toggle switches, and those are pretty susceptible to changing states when thrust is applied. And then the twisting wires is generally not recommended either. It's an acceptable backup, but not when you design to it. That's basically, you have a lack of a switch and you thread two wires out and you twist them together to turn it on, and it works, but it's not ideal. So the Missile Works and Featherweight, those are screw switch examples, and then there's a magnetic switch also as an example. Let's see, power sources. We kind of touched on this earlier, that each altimeter you have needs to have an independent power source or battery. Generally, it's one of these, a 9-volt or a rechargeable battery. And you just need to make sure it's secured. Like if the battery is, you just tie it with a piece of yarn or something, and when you go to launch it, that yarn will break or it'll kind of come off, something like that. You want to make sure it's in there very sturdy. And I have some examples of how you can secure those in future slides. And also Frank is showing an example too. Thank you, Frank. That's a 9-volt battery secured to a sled. Okay, so switching topics, tracking, it used to be optional, but so many teams lost rockets that we make it a requirement now. That it's basically, once you launch your rocket, you have some way, either GPS or radio data, knowing where your rocket is, so you have an idea of where to go look for it. If it's miles away, you know where to drive to go look for it. And there are various off-the-shelf GPS trackers similar to the altimeter companies, and just whatever you choose, make sure you test it, go drive it around in a car or something, or walk around campus with it, just so you know how it works. But the trackers, you need two parts, because you need to get data from the ground, and then needs to be something on the rocket to transmit. And then there's some of them that transmit in amateur radio bands, and for that you need a license, a ham radio license, and that's an option for you if someone on your team would like to get your license. But there are also plenty of options that are license free as well. And then so for the license free band, those are the radio bands to look out for, and the ones that require the ham radio license. The technician class is the lowest level of ham license that you can get. And our recommendation is at the bottom there. There's a specific amount of transmit power we recommend. Let's see, these are the frequencies. Yeah, this is just an example of the entire RF spectrum that's regulated in the US, and each of these is used for some application, medical or fire, or television or space communications. And the FCC is very particular if they're misused. So definitely do not use a amateur radio band device if you're not certified. You will get caught. So these are some examples. Featherweight, Altus Metrum, Apogee make some good ones, and they also need to have your separate battery switch with them. You can have two of them if you want, but it's not as critical as the parachute deployments. That one you definitely need to have two separate altimeters. The tracker, you could get away with one. Ideally, if you have budget, redundant trackers is a nice way to go, but they are more expensive. So you could get away with one if you need.
Have you ever had someone use an AirTag?
We have not, no. That's a pretty new technology. We have not tested that yet. Feel free to test it if you want. Run some tests, report it in your reports. And then so these are some examples of ground stations. Like some of the RF ones, you'll have like a Yagi looking antenna like that one in the upper right. And others will be more handheld, like that Apogee one, or a little plastic box like the Featherweight down there that pairs with an app on your phone. So they come in different forms, but they all have some kind of antenna that you have to point where you think your rocket is and then receive it either on a dedicated device or something tied to your phone or a computer. Even if you need a laptop, you need to make sure your laptop's charged when you bring it out to the launch site. So these are some examples as well. Okay, and this is the last thing I wanted to touch on. This is mainly how to secure your altimeter and trackers. The avionics bay is what Frank showed earlier. It's like a separate tube that has bulkheads on either end that protects the electronics from the black powder on top of it from the main parachute and on the bottom of it from the drogue chute. And it's usually put in the middle of the rocket like that, the electronics bay down there. And we'll have some examples here. The flat piece of wood or plastic that you tie the electronics to, we call that a sled generally. It's like the black one up there is a plastic one, or there's a plastic one that's a fiberglass one up in the top right, top left, sorry. And you could also do wood ones. And then the reviewing that switch band again, or you also call it the vent band, is that ring in the middle. This bottom picture, you could see that hole there. That's your vent hole. So that's usually what you calculate from your reports, how big a vent hole you need. So switches and vent holes both go on the same band. So 3D printing is an option. This blue one up here is, and I believe the one on the right is 3D printed as well. These are just to give you ideas. And the top left one, the fiberglass is fastened to two PVC pipes that go over a threaded rod, and those threaded rods connect the fore and aft bulkheads, and that's how you screw it together and fasten it. That's an example. See, here are a few other examples too. The one on the right is a pretty small one, a minimum diameter. That the tracker is the featherweight. Those are built to be very small diameter, fit in small spaces. Generally, the ones nowadays are pretty small, but you do need to fit a battery in also. And let's see, the orange one on the right, they have both a screw switch and a rotary switch, which are not recommended, but the screw ones, I don't know if you could see my mouse, but the one on the left and right of the orange sled are screw switch examples. Oops. And then besides the actual material that you choose, or including the material, there are some you should avoid. Carbon fiber is well known for blocking radio transmissions. So if you choose to have a carbon fiber airframe, just for the part where your altimeter or your tracker is that needs to get radio signals in and out, just make that part not carbon fiber. So fiberglass is fine. Different types of paper is fine. Just avoid carbon fiber. And then metal and metallic type materials are against the rules in our competition, but generally are not good for RF transparency either. So just avoid metal in your airframe. You obviously have to use metal for like the screws and threaded rods. Just don't use it on the outside of the airframe as the tube. And then just make sure to have the right vent holes, as we mentioned earlier. And if you don't have your copies of these books, those are good places to read about how to make your avionics bay, and has lots of examples. And then always, of course, our handbook can help you with that too. And then more mounting stuff, just make sure your wiring is as secured, that your soldering is done well. Don't use the wrong kind of wire, because thicker and thinner wires are designed for different types of voltages. So just make sure you use the right kind of wire. And if you do choose to use accelerometers or gyros, just make sure they're pointed in the right direction. Those are very particular to being pointed up or to the left or down, and make sure they're just very solid when you mount those, and test them as much as you can as well. These are some more examples. These are both plywood. So plywood sleds. The one on the right is a double-decker sled. They put a battery in the middle. You could put your altimeter on the top or bottom. Here's some more examples. Again, that threaded rod and the picture on the right goes through. That yellow is a 3D printed 3D sled with different sides on it. So that's an option if you'd like to design it and manufacture it that way. And then this is just the review. So when you think about avionics, we talk about how to mount them and prevent them from going awry, make sure they're RF transparent, electrical connections are good, you have the proper vent holes for your pressure sensors. For altimeters, redundancy is key. And actually something we didn't talk about, the time phasing, the ejection charge. That just means your redundant altimeters, instead of having your altimeter 1 and 2 deploy the charges at the same time, have them deploy like 1 or 2 seconds apart or 50 feet apart. That way, when you fly your rocket, you can see them both go off to see if they work. Because if they go off the same time, you have no way of knowing if one went or both went. So that's what the time phase was. And then besides that, test if you can, make sure you know how it works, and make sure your black powder is sufficient for your avionics bay. So with that, that's all I had prepared. We can move on to questions. Looks
Thank
like there's some in the
you,
chat.
Aaron. Do we have some questions? in the chat?
School names. Great,
All
thank
school
you.
names. Does anybody have any questions about avionics?
I do. Helen from CC. Can you go to slide 8, please?
Yeah.
All right. Okay. According to this diagram, there'll be like 4 charges that we have to make.
That's correct.
Okay.
It's not, this is optional redundant circuit. It's recommended you have a redundant circuit.
Well, the thing is that could, let's say for the draw charge, both altimeters go to just one.
No, they don't go to one charge. They go to separate charges. So you'll have 2 charges on each end.
Okay. So again, 4 black powder charges that need to be done.
Yeah.
Okay, that's
Yeah.
okay.
It's possible to go to one charge, but that's not how we recommend. That's a single point of failure.
Okay.
So we recommend 2 on each side for 4 total.
It's no longer an independent circuit if you run it through the same charge.
Yeah.
All right. Okay. Thank you. Can we go back to slide 5, please? Okay. Test the altimeters in a vacuum chamber. I take it you want to make sure your chamber can go at a reasonable altitude. Let's say it can mimic 4,000 feet versus 40,000 feet.
This little vacuum chamber I have here.
Yeah.
A mason jar. I can get it up to 3,000 feet.
Yeah, I mean, yeah, because we tried once on ours, and it recorded like an altitude like 40,000 or 50,000 feet, where we're not going that high.
No.
Yeah. Okay. Yeah. So you need to know that your chamber can go at a reasonable altitude, right?
Well, a reasonable altitude also has to function at that apogee that that it deploys at apogee.
Yeah.
And it deploys the main that you have programmed in your altimeter.
Okay. All right. Okay. All right. Thank you.
Sure.
Tyler?
I was wondering if the GPS tracker has to be off the shelf.
Yeah, highly recommended. It's COTS. If you're gonna fabricate or build something from scratch, you could be redundant. So you could purchase the COTS and then have something else that you're gonna test or compare to the COTS tracker. What did you have in mind?
Yeah, our plan is to have one off the shelf redundant and then try to build one from scratch ourselves. But I was just curious if for some reason our off the shelf didn't arrive in time or something, if we would be allowed to just use the one we made.
Yeah, that's fine.
Okay, thanks.
Question. So the
Go for it.
AirTag is 100% workable. You could actually use an Apple AirTag. Is that allowed?
Is Apple AirTag? How is that tagged? Is that
I think
through,
Yeah, through 2.4 gigahertz, I think it is.
right? So is that Bluetooth dependable, or is that satellite dependable, or is that through the phone that you're using
For the
dependable?
Wi-Fi.
You know, I'd have to research it. I think it's through the 2.4 gigahertz signal, the Wi-Fi.
Yeah, you got to see if you have always constant communication though with it. Sometimes it's kind of sketchy off and on.
Yeah, probably not. I was just thinking about it.
Test, test, test.
Yeah, I mean, the Apple AirTags could be a backup, like a redundant feature to one of the rocketry GPS systems.
Right.
We kind of prefer one of the rocketry COTS systems, such as the Featherweight or the Altus Metrum systems. I think MissileWorks also makes one.
Yeah. The rocket community, when they talk about tracking it, that Apple AirTag rarely comes up. Rarely, so it must not be too dependable. If you want to find a rocket now today. Yep.
And you might have range issues with the AirTag also. Like the rocket might land 100 more thousand feet or a mile away from any other Apple devices, so it may not even know where it is.
I remember going through the woods looking for other rocket, and it was pretty fun. But yeah,
The key issue here, any kind of GPS or tracking device you have, always watch what direction your rocket went. Because at least if you get close enough to it, you'll pick something up.
Got a question about the GPS as well. So
Yes.
this has to fit in the avionics bay as well too?
It doesn't have to.
No, you
It's
put
up
it in
to
the
you where
nose
to-
cone.
Be nose cone, be between
Separate.
the fins. You can put it wherever you want.
Yeah.
Yeah.
Avionics bay is just a suggestion.
Yeah,
It's not
yeah.
not required. Design is up to you.
Okay. All right, okay. Because there are times when we cannot just open up the nose cone.
Right, you can actually make a little case for it if you want to, in a tube,
Mhm.
and seal it up if you have to, and just strap it to the recovery straps.
Oh, so be deployed with the main chute hanging
Exactly.
down.
Right.
Okay, all right, okay, thanks.
And you guys said tracking is required for the competition, or is this a suggestion?
It's required.
Yeah, required.
It's required. Okay.
Redundancy is not required for tracking though. The presence of tracking is required though.
I'll be doing a webinar next week on recovery, and I've got some stories about keeping your head on the swivel on recovery. It's a good idea.
That's a great segue, Frank. You are correct. We do have another webinar next Tuesday at 4 p.m. Central Standard Time. It is on recovery. Frank is going to be hosting that. So we encourage everybody to be in attendance. There'll be a lot of interesting and informative information. So I hope you guys are able to come. If there aren't any other further questions, we're going to go ahead and stop the recording now, and feel free to log off, and we'll see you next week. If you do have any further questions, we'll stay on for a couple minutes. So thank you, Aaron. Thank you, everybody, for being in attendance, and
Thank you
have a
everyone for
great
coming.
rest of your day.
Part is